Hey, how's it going, everyone? In the last lesson, we checked out how we could create classes and objects in Python. In this lesson, we'll continue with OOP and look at inheritance. The basic idea of inheritance is creating a new class based on a different class. Let's see that in code. So I have my player class here and I've just removed the ammo property. And let's say that our game has a few characters we can play as, and each of those characters have different abilities. So what I'm going to do now is I'm going to create a new class. Let's call this Knight. And to inherit from our player class, I just need to put in some parentheses and say player in the parentheses. Now our Knight class is inheriting all of the properties and behaviors of the player class. For now, I'll just say pass. Pass just basically means we don't want to define anything for this class at this point in time. And then I'm going to create an object of the Knight class. So let's say k equals Knight. So that's an object of the Knight class. And now I'll just print k dot health. And I'll also run the walk function from Knight. Notice that the Knight class doesn't really have anything defined for it, it's empty. So if I go ahead and run this now, stop python hello.py, you see we get 100 and walking. So even though the Knight class is empty, we still get 100 in walking, and the reason for that is because the Knight class is inheriting all of its properties and behaviors from the player class as we have defined here. So all of the properties and behaviors that are in the player class are available in the Knight class. So let's create an object of the player class as well. So I'll just say p equals player, and if I print p.health and p.walk, you see we get the same thing. Let's change this a bit so that it's easier to identify which is the player and which is the Knight. So I'll just say Knight here, and I'll say player. And for the walk method, for my player class, I'll just say player walking, right? So if I run this, you see we get Knight 100, player walking, player 100, player walking. So even though we are running the walk method for the Knight class, we still get player walking because it's really using the method as defined in the player class. What if we wanted to say something else for the Knight class? So what we do is we'd override the technical term for this. We'd override the walk method in the player class. And the way we do that is in our Knight class, I'm just going to say def walk self and print Knight walking. Now if I run this function, you see we get Knight 100, Knight walking, player 100, player walking. So now when we call the walk function in the Knight class, we get Knight walking. But when we call the walk function in the player class, we get player walking. What if we wanna override one of these properties here? Well, we can do it the same way. So I can say health equals 120. And if I run this, you can see Knight has a health of 120 while player still has a health of 100. By the way, the class that we are inheriting from, in this case player, is called the base or parent class, while the class that is inheriting, in this case the Knight, we usually refer to it as the sub or the child class. So in this case, player is our base class or parent class, and knight is our subclass or child class. Now let's say we wanted to run the walk method from the player class before we printed this knight walking. In this specific case, it might not make sense, but you may have cases where there's something that happens in the parent classes method that you wish to do before you actually do something else in the child class. So let's see how we do that. All I have to do is in my knight class, before knight walking, I'm going to put in a new line and say super parentheses dot walk parentheses. Super basically calls the parent class, and walk is the method we want to execute from the parent class. I am also going to add in a dash between my knight and player information on the console, just so there's some separation. And now if I run this, you see we get knight 120, player walking, knight walking, and then we have player 100, player walking. So once again, essentially what's happening is when we call super, it basically references our parent object, and we are calling the walk method from our parent object. So in this case, it's basically calling the walk method from our player object. Now this super.walk, you don't have to put it before, you can actually put it after as well, and it will work the same. You can see it's a matter of when you wish to run the method from the base class. Now we have our knight class. Let's say we wanted to create another character for our game. So I'll just say class, let's call this vampire, and it inherits from our player class. And for a vampire, we'll just add a new method for bite, right? And we'll just say vampire biting. And what I'll do is I'll just create an object for our vampire class. So that's v equals vampire, and we'll print the vampire's health, v.health, and we'll run the walk method and the bite method. Okay, just clean this up a bit so that it prints nicer on the console. Okay, if I run my code now, you see we get knight 120, knight walking, player walking. So this is from the call to super. And then we have our vampire 100, player walking, because the vampire class is not overriding the walk method from the player class. Vampire biting, so that's from the method we defined in the vampire class. And then player 100, player walking, so that's from the player class. Now I can also define new methods in the knight class as well as new properties. There is no limitation on that. So if let's say the knight wanted a new behavior for, let's say, swing sword, that's absolutely fine as well. Swinging sword, and I can say k dot swing sword here, and you can see that works as well. No limitation on that. Cool, so that's all for inheritance. Thanks for watching and happy coding.